Okay. Now, okay. Now, see, we'll continue the next topic. Now, see here. See, we are going to learn about potential difference. The potential difference between 2 points in a circuit, okay, carry some current, means carrying some current, you can say. Otherwise, carry some current or carrying some current, anything is fine. Okay, carrying some current is the work done to move unit charge from one point to another. Means if you take a circuit, okay, so from one point to another, whatever the work is done, okay, that we can okay, write it as the work done to move unit charge from one point to another, and you can write the formula like this: V is equal to W by Q. Means it means that actually literally it means that if you, for example, if you take a circuit, for example, this is a circuit, plus minus you take, and this you tap key, and this is ammeter. Ammeter is a device which should be connected in series, and also it measures the current, okay, that you remember. Now say I am taking okay, I am taking a bulb here, and like this I am connecting, for example. Now for example, this point is P, okay, or X and Y, 2 points we are taking, for example. So in between these 2 points, whatever the work done in moving a charge, okay, means unit charge will take generally. So that, so to carry unit charge, how much work is done, okay. So it indirectly it means that the energy spent, okay, energy spent, okay, per 1 coulomb of charge. So that is the meaning actually. So now coming to the next, SI unit is volt, okay. It is named in honor of the scientist Volta. Alessandro Volta is the full name of the scientist. And whenever you write the, as I said, you symbol, you write capital V, okay. Of course here I will write capital V. And when if a definition is asked on 1 volt, okay, means what is the SI unit of potential difference, just like how we got in current, like that a question will be asked, what is the SI unit of potential difference, and define it like that. So what you have to say, okay, so when 1 joule of work is done in moving unit charge from one point to another, then the potential difference between the 2 points is said to be 1 volt. You are right. Means this only you have to convert into sentence form in a mathematical form I have given. So that you have to, so based on this formula we can write this, and this you have to convert into sentence form. That's it. Okay. Now coming to the next. See, there is a difference between potential difference and electric potential. See, generally when we take electric potential, you have to take from infinity. See here, means you are taking this unit charge, okay, there is one source charge here, okay. So when you are here, actually the influence of this charge at infinite means uncountable distance, something like that, very far. So thereby its influence on this charge will be very less. Means the source charge influence on infinity distance at infinity distance on any unit charge will be almost zero. Means its influence will be zero, means the force acting on it will be zero. So when force acting on it will be zero, work done will be zero, okay. As you know very well, work is equal to force into displacement. If force is only zero, then zero into something will be zero, okay. So in that way we can get, so thereby the, if you are bringing from zero, means zero force required, so there the charge can move freely. Now when you are bringing from here to a point P, so we are applying some force to overcome the repulsive force, that is nothing but due to charge now. So we say it as electrostatic force, because it is repulsive only, but it might be attractive also, like that. So because the force is acting due to charge, we have to say electrostatic force. Now, so whatever the work done in moving, okay, the charge to the until the point P, okay, in carrying this unit charge is nothing but the potential at the point, at that point, means at that point P the potential, okay, is said to be what, V, okay. So that is nothing but, again you can write as a formula as V is equal to W by Q, like that. So work done in moving a unit charge. So definition you can say the electric potential at a point is the work done in moving unit charge from infinity to that point, okay. So in that way you can write. Now what we will do, we will go to the next some symbols, and we can go through the next concept, like what is Ohm's law, what is what are the factors on which resistance depends, and all we can go, and combination of resistance and heating effect of electric current, and how we will get the electricity bill. So that problem, of course, those all will go, okay, one after the other. Now let me rub the board and we will go to the next, okay. Okay, right. Okay, now see, now we are going to learn about the different types of symbols used in the electricity, okay, right. See, I wrote the table, you can pause the video and you can write all the symbols and all, but I will explain what does it mean and all. See, generally serial number 1 2 3 4 5 6 until 11 I wrote, as we have in textbook and all. okay, and a component name I wrote, and I wrote symbol. Okay, here also same similar. Okay, serial number, component and symbol. Now see, whenever we are using, see generally out cell, for example you are using remote battery etc., that is called as actually dry cell. So generally that cylinder shape it will be there generally, but in physics what we do, instead of drawing the total whatever the cell we are using in a torchlight or a remote control etc., we don't draw, no need to draw that much. Okay, so simplified way what we represent in the circuit is like this. Okay, so what is that is, one we are drawing horizontal lines, and in the middle of horizontal lines you have to break that horizontal line, and you have to draw one larger line which indicates positive charge, and one smaller line, okay, vertical line, okay, which is a little smaller than the previous one, that is plus line. Okay, that is nothing but positive, which indicates positive, and thereby this minus line, okay, means the vertical smaller line indicates negative. So means it mean that so for a battery there will be two terminals, plus and minus, so it indicates that positive and negative terminals, like that. That is only for one cell. If you are using more than one cell, then we say it as battery. Okay, so more than one cell. See, in textbook they give actually 3, okay, plus minus like that, 3, but even so, see, since I deal for IIT and all, NEET syllabus and all, for 11th and 12th and inter and all, state syllabus and all syllabus, more than one, okay, if you draw then it is okay, it is nothing but a battery. More than one, okay, means it, that is the reason I showed you 2. Okay, even 3 is also fine. More than one, if it is there, it is battery. Now coming to the next, plug key or tap key, plug key or switch. If no dot is there in the middle, that is open, it means that it is in off position. Actually, what is this? Actually, this will indicate off, this will indicate off position, OFF off. Okay, I will write somewhere here OFF off. If it is closed, then it indicates on position. Okay, on. Okay, so that you can write. Okay, no dot means off position, that is nothing but switch open, plug key, switch open, plug key or switch closed. Okay, when dot is there, that is nothing but on position. And whenever you are joining, for example you are taking a circuit and you are joining this, so current from this is passing into this, like that, then whenever there is a okay, current passing from one wire to another wire like this, then we call it as wire joint. But simply wires are crossing over the other, but no, from this wire, for example this one wire, so from one wire to another wire, if the current is not passing, that time what we have to say it as, we have to draw like this. Okay, it means that wires are crossing without joint, means current in this wire is not passing to this horizontal line. Okay, understood, that is the meaning. And coming to the next, electric bulb. Electric bulb simply a little like similar to M, like that you write, or otherwise act like actual electric bulb you can draw. Okay, that is electric bulb symbol. And coming to the resistance of resistance R, see generally like this zigzag line. Okay, you can draw, that is nothing but resistance, or some people will say it as like M only you draw, like that. Okay, that is also fine. So that is nothing but resistance, resistor of resistance R. Resistor I will write, resistor means, see, this word resistor is derived from the word, see, every conductor will have some resistance. For example, even if you take copper wire or any wire, aluminum wire or anything, it will offer some resistance. So resist or resistor means conductor is nothing but it will offer resistance. So resistor word is derived from the word resistance and conductor, like that. So because every wire will have some resistance, resist and conductor means or, resistor. So it is nothing but one type of material which will offer some resistance, that's it. Okay, now resistor of resistance R, so that symbol. Okay, like zigzag line, like that. Okay, and variable resistance means without changing battery, sometimes we want to increase or decrease the current. If you increase the resistance, then what will happen, the current will decrease. See, as I said you, resistance is actually, it is nothing but the obstruction offered to the flow of current by the atoms present in the conductor. Okay, so in that way, if not conductor, you can say any material like alloy or semiconductor etc. So that is nothing but this is nothing but variable resistance. Variable resistance, another name is rheostat. Okay, and you can draw zigzag line and keep one obliquely one arrow or like this. Okay, and this one again you draw zigzag line and keep one arrow like that. Okay, see, arrow, some students argued with me that No, left to right only arrow should come. No, it can be in right to left also, left to right, nothing, no problem. It is called as variable resistance. As textbook says, I drew like that, no problem. You can draw from right also. And ammeter is a device which should be connected in series, and also ammeter will measure the current. It should be connected in series in the circuit. Okay, voltmeter will measure the potential difference, and it should be connected in the parallel to the whatever the appliance you are using. Okay, like bulb, etc. Okay, or any wire like heating element like nichrome wire, etc. if you are using, then okay, to that wire you have to connect it in parallel. Okay, so this is about the way. Now we will go to the next. Okay, now see, this topic is about the Ohm's law. See, what the scientist Ohm said is, whenever like a circuit, if you are increasing the battery, for example, say you are using 4 volt battery, 5 volt battery, or 10 volt battery, whatever it is. So if you go on increasing, what will happen? The current will increase, right? So current symbol is generally we will take from what you call from plus, and the symbol for current is I. So like that, the current will be passed like this. Okay, so this wire we can say it as nichrome wire. Okay, some wire we are taking. Okay, now so through the nichrome wire, what we can do, we can what you call pass the current, and thereby we will measure the ammeter reading. And this is a switch or tap key. So if you keep dot, it is on position, current will pass. So we will get ammeter reading. Okay, this one current, and we will get voltmeter reading. Okay, these two you can write. And then next what you do, go on increasing the cells, means another cell you connect, and this dotted line, that is the reason it indicates that we are connecting more than one cell. First one cell we have to connect, then second 2 cells, then third 3 cells, like that. So again you note the ammeter reading, voltmeter reading, and all, note the values. And you will notice that if you, after writing all these, if you will notice that V by I values are always constant. It means that current is increasing proportionately with the potential difference. Means V and I are directly proportional. That is the meaning. So that is the reason Ohm's law, what it states, the definition. So the potential difference across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it. Means simply if you say provided, actually we should write one more line, provided for the same physical condition, means provided temperature remains the same, and material length, area of cross section remains same, right? So temperature remains same, and remains same, you can write, and for same physical conditions, comma, for the same physical conditions. What does it mean? Physical conditions means when you are performing this experiment, you should not change the material. Okay, nichrome wire if you are using, you should use a nichrome only, and you should not change its length or thickness, means its area of cross section, etc. You should not change. That is the meaning of physical conditions. And also temperature remains same, means anyhow you should not increase its temperature by yourself. Okay, of course, because of the passage of current, it may increase slightly, but but we should not. Okay, in that way you have to do this experiment. Now, so if you take some values randomly, for example, I will take randomly some value. For example, I am taking this point, 4th point. For example, I am taking some 8th point. Okay, this one. Proportionately you take the corresponding points. Okay, for example, this is 0.2, and this okay, 4th point. Okay, 6 points. Okay, something like that we can take. Okay, now so what you can do here, you will get a triangle like this shape. Okay, like this. So you have to find the slope. So what you will do, this is V, potential difference, and this is I, current. Okay, so you take, for example, you mark the points as A, B, C. So when you find the slope, means what you will do, generally slope means here y2 minus y1, means on y-axis 2 points, y2 minus y1. So it is nothing but v2 minus v1. Okay, take 8 as v2 and 4 as v1, like i2 minus i1, means take this some point 6 as v2 and this one v1, like that. So the slope will give the resistance, like 8 minus 4, okay, by 6 minus 2, so 4. So okay, so 8 minus 4 by 6 minus 2, so 4 you are getting, right? So any okay, 4 by 2 you are getting, so you are getting 4 by 4 you are getting, and thereby you will get 1. Okay, means like 0.2 now. Okay, so you will get 10, 0.2 now. Okay, 0.6 means you will get 0.6 by 0.2, so 0.4 means you will get a 10. Okay, like that. So 10, so the slope will give you resistance. Actually the slope will give you resistance. R is equal to delta V by delta I, or something like that you can take. So this is units of resistance is Ohm, like that. Now So this value always it will remain constant, means instead of taking these points A, B, C, you can take another triangle like this also, means for example you can take some point called here 10 and some 14 point something like this you can take. For example, extend the graph, you will get. So these two again you can take another right angle triangle and again you find the slope. Anywhere if you find, again you will get the slope value as constant. For example, if you are getting here 10 ohm, so always you will get 10, 10, 10, 10. So this verifies the Ohm's law. So that is the meaning. Okay. So this we can do in the laboratory also, and you can enter the values and you can show it. Actually it should be done in the practically. Okay, the school should supposed to show. Okay, now so this is about the law, and whenever V is proportional to I, you write proportional constant, and whenever you remove proportional symbol, you have to keep some constant in physics and use is equal symbol. And if you bring this I, it will be V by I is equal to constant. V by I is equal to, in the place of constant you write R, where R is the resistance of the wire, right. So now you can connect the circuit like this, and you can enter the values and draw the graph and find the slope. So whenever you are getting, if you draw a graph, whenever you are getting a straight line, it means that it is a okay, it is a what you call this conductor is obeying the Ohm's law. Okay, so it means that V and I are proportionally increasing. Okay, and see, there are some limitations also for this. Okay, that also I'll say 1 minute. But see, if in exam explain or describe an activity for to verify Ohm's law like that, if they give, you should write like this. First of all, you have to say aim of the experiment. Aim of the experiment is to verify Ohm's law. Then you have to say materials required. So when you want to remember materials required, first look at the circuit diagram. So if you remember the circuit diagram, okay, you can see cells are there, ammeter is there, voltmeter is there, type Q is there, resistors, nichrome wire of some certain resistance R is there, like that, and conducting wires are there, like that you will have an idea. So remember, that is the reason remember circuit diagram. So next is materials required, you have to write. Third one is procedure. Procedure, what I said, first arrange the circuit as shown in the figure, and first connect one cell and note the ammeter reading and voltmeter reading, like that I said. So that process you have to explain. And next, after noting the readings in the table, now join one more cell, and now the note down the voltmeter and switch on the circuit and note down the voltmeter and ammeter reading, like that you have to say. And again, so you have to continue the procedure. Then after completing the procedure, then you have to write this table and you have to draw the circuit diagram and you have to draw the graph, and in that way this experiment will be done. Okay, now this is about Ohm's law. And see, generally these limitations of Ohm's law, generally it is not given in the textbook. It's like out of portion for you, but just for randomly I am saying. See, this Ohm's law for larger values of Y, okay, means if you go on increasing this potential difference, more battery, it won't come straight line. Actually you will get like this, means what I mean to say is the current won't increase proportionately with voltage, means like this you will get. Okay, this curve will go like this actually, instead of going, actually it should be straight like this, right. So in that way, so means for higher battery, if you go on increasing the batteries etc., potential difference when you increase, it won't be straight. That is one thing. Second one is, anyhow you know very well, see, this we are taking plus, battery plus. For example, battery terminals, if you interchange plus to minus, then okay, means actually when you go like this, okay, means this is actually down one you can take minus V, and this you can take plus V, like that, na, plus current in the opposite direction, so minus I, like that. So what will happen, the current won't be proportionately reversed. Okay, so on reversing the battery, so this will happen generally in diodes. So that is also, one defect. One defect I said you, the V and I are not proportional for higher potential differences, that you are right. Second point is for diodes etc., on reversing the terminals, okay, on reversing the potential difference, the current proportionately won't get reversed. So that you can write. And there will be one what you call substance called gas, gallium and arsenic, okay, that we said as gas. For this gas, when you are that material, when you are passing current, okay, for the same what you call, you will get the same current for two different potentials. Okay, so that is also one defect. Okay, means for the two different V's you will get same I. Okay, so in that way, so that you can say this all. But anyhow, for now what you can do is you can skip this limitations, but generally these limitations are not in portion, but orally I said you. Okay, now pause it.